Hello student, the question says a cylindrical piece of cork of density rho, base area A and height h floats in a liquid of density rho 1. The cork is depressed slightly and then released. Show that the cork oscillates up and down in simple harmonically with a time period t equals to root of h rho by rho 1 g, where rho is the density of cork. We have to ignore the damping due to viscosity of the liquid. So imagine we have a cork of base area A and density rho. And if I try to draw the free body diagram for the given case, so when we draw the free body diagram for the given case, the first force that will act on this cork will be mg. So the mass mg would act on this downward. There will be one upward force known as force of buoyancy that would be acting on this. So this will be the, let us say, force of buoyancy. Now at equilibrium, originally it was floating. The question it is given. So floats means force of buoyancy is equals to mg. Let us assume the length that is inside is some, let me call it as L. L is the length that is inside. So we can say when floating, the condition is that force of buoyancy mg will be equals to Fb. So mg is equals to, what is force of buoyancy? Force of buoyancy is volume inside into density of fluid into g. This is the formula for force of buoyancy, volume inside into density of fluid into g. What is the volume inside? L is the volume inside. So we can write volume inside is L into base area. So L is the length that is inside into base area A. It will give us the volume of the cylinder that is inside into density of fluid into G. Density of fluid is given as rho 1. So from this, we can tell simply mass is equals to LA into rho F. So let us skip this. Now this will be useful in the next process. Now what we did is, for this given cylinder, we took it and we slightly moved it by a distance x. So what happens when you take a cylinder and slightly move it by distance x? When I slightly move it by distance x and leave it, we know force of buoyancy depends on volume inside. Originally, both are exactly balanced. Mg is exactly balanced by force of buoyancy. Now, if you slightly move it down, you are increasing the volume inside. When you increase the volume inside, I will do it drastically so that you can clearly see how drastically increased the volume inside. When I increase the volume inside, my force of buoyancy increases. So originally, let us say the force of buoyancy is 100. Now the force of buoyancy might become 200 because volume inside increased. But our gravity only depends on the mass of the body. So there is no change in mg. So force of buoyancy would suddenly become a very large function because more volume is inside. Our gravity would remain as it is. The same gravity would be present. Same mg would present. This mg will not be able to balance the new force of buoyancy. So let me call this the new force of buoyancy. And this is my mg. Now originally L was inside. So whatever L was there, extra I have immersed x. But again, I will tell you this x has to be very small, or else like there will be other factors that would come into picture. We are assuming x as very small only to explain you. I have drawn it a little bit, or else if you take this cylinder, it has to displace slightly. It will keep on slowly moving up and down in this way. There will be very little oscillations, like it will slightly go up and down in this way. For explaining purpose, I have drawn a large L. Now let us take this entire thing to the next page. So we have a surface and we have a cylinder. So this is my cylinder. Like most of the cylinder is inside now. This will be X. This will be L. L was the original length that was inside. Now two forces, mg and force of buoyancy. Now we can clearly see the new force of buoyancy is much greater than mg. Since the new force of buoyancy is much greater than mg, the net acceleration would be upward. Because mg will not be able to balance force of buoyancy, the body will have an acceleration upward. So according to Newton's laws, if mass is constant, net force equal to mass into acceleration. So in net force is simply the new force of buoyancy minus mg is equals to mass into acceleration. The new force of buoyancy, I can simply write the new volume inside into density of fluid into g minus mg is equals to me. Now, what is the new volume that is inside? It is L plus X. This is the length into base area A into density of fluid into G minus mg is equals to mb. So let us multiply this. So you will get LA density of fluid into G plus XA density of fluid into G minus mg is equals to mb. In the earlier result we got LA into density of fluid into G is nothing but mg. So I can cancel this mg term and this term. So what is left out with it? XA density of fluid into G is equals to ma. So we basically got A equals to XA density of fluid into G divided by m. So finally, this is the value that we got. This is in terms of magnitude. If you look at exactly vectorially, we know in SHM, the acceleration, the direction of acceleration would be minus omega square into x bar. Like whatever is the direction of displacement, the direction of acceleration would be minus. Even though we write simply a equal to minus omega square x, here x and a are proper vectorial representations because magnitudes can never be negative, right? So if you notice it, if the displacement is down, the acceleration is upward. Both are in opposite directions. Then why didn't I get the negative sign? Means here I am only considering the magnitude. If I take it with proper directions, I will get with a bar equal to minus x bar a then rho f g by m. So in this only, if I just take the magnitude expression, magnitude of a bar equal to magnitude of omega square into x bar. So simply a equals to omega square into x. If I substitute that here, so x into a density of fluid into g divided by capital M is equals to omega square into x. So this is a simple example to say since a is proportional to x, this will follow a simple harmonic motion because the first question is that it is we were asked to prove that it is an SHM. Whenever acceleration is proportional to minus 6, where a bar is proportional to minus omega square x bar, this is an SHM motion. The displacement is downward, the acceleration is upward. Straight away we can tell that this is an SHM motion. The negative sign is not there because these are magnitudes. If I do it vectorially, we will get that negative sign. So a equal to omega square x, and he is asking us to find the time period also. So omega will be equals to root of rho 1 a g divided by m. So from this, time period would be 2 pi by omega. So you will get 2 pi by root m by rho 1 ag. He's asking us to do it in terms of h rho. We already know what is mass of a body. Mass of a cylinder or a cork is nothing but height into base area. So if I substitute height into base area, that is mass of the cork is simply density of the cork into volume of the cork. So density of the cork into volume could be area into height h. Here we are assuming the cork to be cylindrical because it is given in the question as cylindrical. So let me substitute it. T equals to 2 pi root rho ah divided by rho 1 ag. So rho 1 would get cancelled. So 2 pi root rho h by rho 1g. So we got the required time period. And this formula is also important. M by rho ag. Rho is the density of think like rogue. Okay, so r rho ag, most of the topics that you see, wherever rho ag are given, they will be side by side. This rogue word is very important. Okay, like we generally get rogue word a lot if you observe it the other formulas in other topics also. The height raised by capillary tube experiment also, 2t cos theta by, you will get uh, rho rg only. Like everywhere this rogue word you remember, it will help you to mug the formulas better. But anyway, t equals to 2 pi by omega 2 pi root m by rho 1 ag, and this is the proof that there is a, it's a simple harmonic motion, so hence proved. The most important thing is, one key mistake if somebody can point here is that I have moved it a little, a bit more to make you understand. Technically you have to move it very little. If you move it very little, it will keep on moving in straight lines in this way. Hope you understood how I have solved. Thank you.